You guys ready for a talk yet? Last talk of the day. All right. I'm Dave Täht, and recently I had a really unusual experience. Yes, sir.
Speak up and speak a little slower, and you do this for us.
Okay.
Oh, you can just go closer.
Well, you guys can come closer. Ah. All right, I'm Dave Täht. Is that better? Yeah. Yeah? I'm Dave Täht, and I recently had a very unusual experience. Most of you guys know I'm deeply involved in the buffer bloat project, and that we fixed buffer bloat. We're just waiting for everyone to roll it out, which has been about 8 years now. The thing is that not everybody's got the message. Fairly recently, we did some tests of some new 5G gear. 1.6 seconds of buffer bloat. We're down in the 10 millisecond range for Wi-Fi, and doing great for that. But I get a little worried. So about 6 weeks ago, maybe it was 2 months ago, a company called SpaceX. Who's heard of SpaceX? Not SpaceX, SpaceX. And they've had a plan for going on about 5 years now for deploying an enormous fleet of satellites, which I've been showing behind me, to provide internet to the entire world, low latency internet. And so I was like, wow, they launched the first 64 satellites 6 weeks ago. And nobody knows a thing about how they actually work. All there is speculation on the internet by one particular guy, Mark Hanley, who's a pretty famous IETFer, among other things. But there's nothing. There's no information about the layer 2 protocol, no idea how it's going to carry IPv4, no idea how it's going to do the uplink or the downlink. The only information the entire world has is 3 FCC filings and a couple patents. And yet they're orbiting overhead today, which is actually kind of cool. So the thing was is that I really didn't want this new network to have buffer bloat. So I put out a posting on Reddit. Mark Hanley had I had a big discussion. And then Starlink called me. Well, actually, I put in a job application first, then they called me. And after a while, talking back and forth about the importance of the concept, the recruiter didn't quite get it, then she did. And then I got all the way up to the vice president of engineering. And I'm still kind of trying to get a job here. I'm a little tired of Wi-Fi. But I did have a wonderful, long conversation about low latency networking with him. And I still, despite that conversation, didn't learn the first thing about how the damn thing actually worked. I'm a little afraid to ask. There's 3 points that are going to fall out of that. Let me hit pause on this. So the way Starlink is supposed to work, how familiar are you guys with geosynchronous internets? Yes? It goes, how much latency do you typically have?
200 milliseconds?
800. 600 to 800 milliseconds of latency going out to geosync and bouncing back down again, which really sucks. Not only that, the speed is really poor and the uplink is really bad. So the Starlink concept, there's a couple other companies doing it, is that presently they're going to put somewhere around 12,000 satellites in various orbits above the Earth. The first batch is going to be at 550 kilometers. This was kind of neat. At the time I was talking to Starlink, I didn't know that. They'd actually had the orbits at 1,100 kilometers, which is about 7 milliseconds of delay. And they lowered them to 550 kilometers, which is roughly 3.6 milliseconds of delay. And I've been scratching my head trying to reverse engineer the protocol, and as best as I can tell what they're going to do, and this is just a guess like everybody else, is that they're going to make it look a bit like Wi-Fi. They're going to have retransmits, they're going to have batchy stuff. It's just, I can't think of any other situation answer that solves the movement problem. If you're in a car, you pass through an obstruction, you're going to lose packets. So they got reordering, they got all kinds of other problems. And the structure, they're hoping to create a pizza box size here. Why is this not moving now?
No, it's fine. Yeah, it's working.
Okay, there we go. So this is what the uplinks look like. You have to change satellites somewhere every 2 to 3 minutes. You have to switch to a different satellite every 2 to 3 minutes. They're moving so fast. They've got spot beams hitting the Earth, which are about, originally they were about 500 kilometers in length. Now they're about 180. Just these things are moving really fast. The cool thing about this whole overall design is it's 3.6 milliseconds to get to the first satellite, and to get from, say, Tokyo to London, it takes about 70 milliseconds less than it does via cable. Speed of light in cable is a bit slower than it is in the real world, and once you get above the real world, you don't have to deal with any of the other problems. SpaceX is contemplating making $30 billion a year from this particular system. And the only way that most speculators think that that can happen is by using stock market arbitrage. But along the way, and of interest to this particular group, is that they are going to be providing internet service all over the world via a pizza box mounted on top of your hut or your small building or whatever. And you'll then be able to route stuff to anywhere in the world from a single location buried deep in the jungle. And I'm hoping very much that when they start delivering those pizza boxes that we can get in on it and go and start pushing out the internet into the Amazon and other places where it's needed. There's a second problem. Anyway, can I have any questions on that much? I have one other problem going forward I want to talk to.
So in Mark Samil's paper, the one we were talking about, he was saying that since this network has a lower latency than the fiber networks, when you go around the world, it would be like a premium service.
Yes.
They will sell this to to market exchange because they can send information faster. So it will be really expensive actually. So I'm not.
I'm hoping it will be really expensive for those kind of applications. Yeah. But when you have a satellite passing over Africa or passing over South America or any given island in the Pacific, they have no use for that satellite otherwise. So there's a natural change in the market. Yes, absolutely. There has to be 2 levels of service priority. So this gets me to 2 of the more interesting problems going forward. Still, nobody knows how this stuff is supposed to work. Nobody. There's no published protocol whatsoever. There is nothing. And this is in part for 2 reasons. One, there's a thing called ITAR. Who knows what ITAR is?
It's the U.S. regulations on what electronics are classified as weapons.
Yes. Anything that goes into space potentially comes down from space. There's an old song about that. You know, when the rockets comes up.
It's not my business, says Werner von Braun.
It's not my department, says Werner von Braun. Yes. So anything that goes into space is potentially a weapon. And even though the Starlink satellites are very small and do burn up in the atmosphere, they're considered to be a weapon.
So and you have another video, Dave.
Sorry?
You just switched to another video.
Oh, well, okay, well. This is still the Starlink stuff right there. That was the launch platform. So I'll just keep talking real quick. So we have a huge problem with ITAR in that most of this stuff here is covered by a really restrictive U.S. Government policy, which is kind of in conflict with GPL because almost all of SpaceX's stuff appears to be built on Linux. They don't have a customer in space per se, so it's okay to ship a GPL operating system into space. But these pizza boxes, assuming that they're Linux-based, suddenly have an interaction with this protocol that nobody knows about that I do hope is somehow resolved because I would really love to know how well the Starlink protocol is going to actually work in the real world as it's deployed to tens of millions of people. And that's it for my talk. Yes, sir.
So,
there is one big difference between what we are doing on Earth and what they are doing in space, which is that the movements of celestial objects can be predicted with great accuracy. So with terrestrial routing protocols, we are assuming, we're measuring things and assuming that the past is a good predictor of the future. So for example, we have all come here because we know that these stocks in the past have been interesting, and we assume that the past is a good predictor of the future. That's what we do when we measure packet loss. While in space, they can actually predict the future. So the protocols are likely to be very different.
All right, I may argue with that in two ways. One, getting from the Earth to the ground has some difficulties. There's cloud cover, there's mountains, there's all kinds of other circumstances that may occur. Satellites fail, there's single event upsets. You know, you can have to reboot your satellite. So there's a lot of failure modes that accompany the fact that everything, that the movement and the changes are deterministic. There's also one that Mark Hanley's been pointing out, is that capacity planning is difficult. We may have to be routing around hotspots in where we've got, we don't want any packet loss in space. We want to do all the packet loss in the ground if we can. So we want to be actively routing around any set of satellites that are extremely busy transmitting stuff directly between, say, London and Tokyo. So they're new problems, they're interesting problems, and some of them are routing problems.
All of them are routing problems.
Okay.
Many of them are routing problems. And I agree with you that they can be interesting problems. What I fear, what I am a little bit concerned about, they will go with a centralized solution. If I wanted to get that to market quickly, I would go with a centralized solution, and that's really sad.
I could see them doing that, but at the same, we don't know. I like a distributed solution because the world is, this potential network is much bigger than just circulating the globe. And also, we should be able to be, when it hits the ground, we'll have to be routing our own stuff. Using, you know, we can take the existing meshy stuff that we have here and apply it to this technology. If we want to get between two villages that are 110 kilometers apart, well, we do an overlay network to get there. Anyway, they've got 64 satellites in orbit. They're projecting being somewhat operational in under 2 years.
Do you have the root password?
Not yet. Got friends working on that. All right, anybody want a song?
Of course.
No, I just brought the guitar as an effect today. How much time do you have left?
1 minute.
All right, so I'm done. Everybody have a great trip, and do look to the skies.
You can actually see them.
Yeah.